Hello folks, we come to the part 2 video of this exercise, miscellaneous exercise of this chapter. Chapter how much? Chapter 11 conic sections. Now this part is going to be a little crucial because we have got a couple of problems which are lots of understanding. Okay. So let's have this problem. What does it say? The cable of a uniformly loaded suspension bridge hangs in the form of a parabola. Hangs in the form of a parabola. The roadway, which is horizontal and 100 meters long, is supported by vertical wires attached to the cable. The longest wire being 30 meters and shortest being 6 meters. Find the length of the supporting wire attached to the roadway 18 meters from the middle, like the previous question. Okay, first we will understand that they say that it's a suspension bridge. Suspension bridge. Do we understand what's a suspension bridge? Yes, it's a suspension bridge that they are talking about. Suspension bridge is basically it's a fun bridge. Okay, you don't use that bridge for heavy activity or for traveling. I don't know, not in my knowledge. It's a fun activity, like you can have it in maybe in parks and things like that. You know, you have two poles and in between the two poles you have a bridge like that. So you can you have a it's either made up of rope or it may be made up of some thick cloth or something like that, so that it hangs and you can visualize the way it hangs like a parabola. That's how it is. We do see it here. We see it somewhere in the parks. We do see it over here down south, and otherwise people who are interested in seeing cartoon things, we used to have things on this channel Pogo, and there we had a thing called as Takeshi's Castle. So it was like that was full of tasks, so you have to do lots of tasks, and you have to get back to some goal, right? And in that there was this task. I remember of having seen it once, and then it is like this man, he is doing a lot of things to reach his goal, or he is given a target, he has to reach the target, out of which one thing is to go through this suspension bridge, and that bridge would be hanging like that until he has to dance and he has to reach. So I don't know, the people who have seen it can visualize it better, or otherwise we have, as I said, down south we have different parks, etc., which has got this suspension bridge. Generally it is made up of, you know, very tightened ropes, so that it just hangs like that. I'll try to make a rough sketch because I'm not good at drawing at all. It may or may not appeal to you, but I'm very sorry for it. You can Google it and you can find some images. You can Google image of suspension bridges, and so that will give you an idea as to how it is. And so when it hangs like a parabola, or just to give you a rough idea of what it is, like you see, we see you know, in many of the movies you see those beach side views, right? So that time we see that the heroes and the heroines, you know, they lie on that kind of that swing like thing, that is like made up of some mesh like thing. They lie on it. Can you visualize the shape, how the shape is? If you can do that much of visualization, then this work is easy. So first what you have to get is that visualization. If that is there in your mind, then this work is simple. So it is a parabola. So first I'll try to draw the rough sketch of it. It is first I'll see how the suspension bridges. This is not important from maths point of view, just to give you an idea, and then the mathematical part I will let you know how it is. The bridge is like this. We will have, as I said, you know, we'll have some meshy thing which will be hanging like this. No, it will be hanging in between the two poles. It would be either made with a rope, or it would be made with some thick cloth, or sometimes it is some kind of plastic wires which are knitted very well, so that it will hang like this. So this is how it is. Obviously you can think of it that when it will hang, it will form a parabola, upsided parabola, type 2 parabola. So that's how this is. This is a suspension bridge. This is what we call it as a suspension bridge. Now we take the mathematical part of it. What all things they have given us lots of detail about it. Let's see what is the mathematical part. There are two poles. They're telling us all this. There are two poles, and it is from these two poles that the suspension bridge is hanging. Okay. Now you can see the generally for fun activity, generally what happens is this is always kept above a water body or something like that, so that there's that fun factor, right? So because people, when they happen to see down, they'll get scared, that kind of a thing, to make it more adventurous. So in order to secure and in order to get it in order to see that it's not it doesn't create accidents, what they do is the suspension bridge, they don't leave it like that, they support it by wires, right? Somewhere down there they are supported by wires. This bridge will be supported by wires. These are the kind of wires by which they are supported. Okay, and that is the data. The question says that this bridge is 100 meters, if I am not mistaken. Yes, the bridge itself is 100 meters long. Totally it is 100 meters long, and this supporting wires, the highest wire is 30 meters and the smallest wire is 6 meters. You can understand, you can guess, like if the parabola is like this, if the lowest part will be this, the highest part will be that, right? So the lowest is 6, highest is 30. That is what the data says. Okay, that's it. So obviously we can, like how we saw the diameter and all that, because these are always parabolic things, they are symmetric. So if we happen to fix a vertex, obviously this much part is going to be 50 meters and this much part is going to be 50 meters. It is going to be like that. Now okay, the bridge part is clear. Now I have to get the maths out of it, like where is the vertex, where is the focus, etc. So for our convenience, because we have learnt of parabolas only at the origin, with the vertex at the origin, so we have our axis here. Let's fix our axis here. So this is our axis, right? This is our x-axis, this is our y-axis, and this is our parabola. Now this is the origin. So let's have these convenient points. A, we can have B, then we can have O, we can have C, we can have D, we can have E. Yes, now it's everything is related to what is asked in the question, like what we have done in so many problems. First we will kind of generalize this curve. After we have generalized the curve, in the general form we will get the equation, then we will get a point on it. Once you get the point on it, we will substitute it. So you will indirectly get the value of A. Having got the value of A, they give a specification that find out a certain thing when a certain thing happens, like what we did in the previous case. That also we will find out. So that is how things are going to work out. I'm not sure whether we have to mark this also or not, but it's okay. Let's mark it. Let's call this as F. I'm not sure whether we'll require it, but F, and let's therefore call this also as G. I don't know whether we'll require it, but let it be there. Yes. So having got this much, and also what they have told us is find the length of the supporting wire 18 meters, which is attached to the roadway 18 meters from the middle. So from the middle you take 18 meters, from the middle you take 18 meters, so till where? F, G. So 18 meters, and here there will be a wire. You have to find out its length. G, H, I, G is over. G, F, G, H, I, and J. So you have to find out HJ. That's the question. So I hope it's clear to you. So this is what everything is all about, and this is what the question is. Once you've got the question, then you have to just diffuse it and get the answer. So let's introduce all this. Let the suspension bridge be as shown in the figure. Suspension bridge. See, if you want, if you don't want the examiner to hunt, you can write all this so that the examiner doesn't have to even read the introduction. Suspension bridge, and these are supporting wires. If you want, you can write it like that to make the work easy. Supporting wires, if you want. And this is the mid path or something they say, a roadway. They give that word roadway. Yeah. Let the suspension bridge be as shown in the figure. Be as shown in the figure. And what all things are there here? Here, DE, OC, AB, JH are supporting wires. And what do we have? We have EB as 100. That makes, therefore, EC equal to CB, which is half of EB, becomes 50 meters. Also, OC is 6 meters. So, therefore, FB will also be 6 meters. Can you see it? Right? By proportion. So, if you want, we'll just figure it out. Therefore, AB, which is made up of AF plus FB, is actually 30, which is made up of 60 plus AF. We don't know AF. That way you can get but AF. AF will become how much? 24. Right? So, this AF is 24 meters. That much you get. Now, more or less, yes. And then you have to tell about this 18 meters. So, you can say that CH, now CH is 18 meters from C. 18 meters from C to find HG. Our idea is to find HG. Right? So that way we have made things clear. Now we have to proceed. We know the strategy, that we get the equation, then get a point, then get the A, and then get the thing. So here we can say that let the equation of this parabola be what? X squared, upward looking parabola, x squared equal to 4ay. We are all aware, type 2. So x squared equal to 4ay. But we have to get a point. So suppose if we are planning to get the point A, so you should get the y coordinate, you get the x coordinate. X coordinate is clear, it's 50, right? And y coordinate, now we have found out that this much length is 24, right? So that is also clear, right? But A with coordinate 50, 24 belongs to the parabola. Right? How we have done all the working and we have shown, because our axis is over here, we know that this much is the x coordinate and this much is the y coordinate. X coordinate we have found out 50 and y coordinate we have found out as 24. So we have it. Belongs to the parabola, so it satisfies. Satisfies means x and y. So 50 squared equal to 4a into 24. So you will get, I think 4a is enough. So 50 into 50 by 24. So it's like 225 times. 12 times, 225 times, 6 times. So 25 into 25 by 6. I think we don't need to diffuse it. Therefore, the equation becomes what? X squared equal to 4a is 25 into 25 by 6 y, or rather x squared equal to 625 by 6 y. So we've got the equation. Now they tell us that suppose say if you have the x coordinate as 18, then what is the y coordinate? That is the question. So let's see. Given that CH is 18, yeah. First what we have to do is, you have to find See, our axis is here, so we'll be first able to find, if we are finding the coordinate, you'll be able to find ij. Then we have to add 6, so we'll get the total length of this wire. That's how it is, because our axis is here, no? We'll be able to get, as a coordinate, we'll be able to get only this. So let, given that this, let ij be equal to k. Therefore, coordinate of j is, x coordinate is 18 and y coordinate is k. J belongs to the parabola, so it will satisfy the equation of the parabola. So what will happen? You will have, therefore, x squared equal to 625 by 6y will now become 18 into 18 equal to 625 by 6y for us is k. So if we are interested to find the k value, it's going to be 18 into 18 into 6 by 625. I don't know if we are doing fine. Is there any problem anywhere? Okay. So 18 into 18, 324 we know. Yeah, so 324 into 6. Let's find 324 into 6. 6 4s are 24 to carry. 6 2s are 12. 12, 14, 1 carry, 18 and 1, 19. Yeah, so 1944, which we have to divide by 625. 625, 2 times, 3 times, all will keep ready. 2 times 10, 2 2 4 5, 6 2s are 12, 3 times is what my intuition says. Let's find out. 15, 6 and 1, 7, 18. 4 also will keep ready. 5 4s are 20, 4 2s are 8, 10. 24 and 1, 25. Obviously 3 times it is 2 5, sorry, it's 1875. So how much it comes to? 4 9 and then 6, so 69, decimal point 690, only once. 625, remaining 5, 8 and 2 6, 3.11. Always we work only till 2 decimal places, so you will have this k value coming up to 3.11 units, whatever that it is. Yeah, we are working in meters, so 3.11 meters. So we are done now. What we are done with? We are done with the ij value. Now they have asked us a length of the supporting wire. That means they have asked us a length of jh, and jh is ij plus ih. Ih we all know is 6. 6 in all the cases, or throughout it's going to be 6. So therefore what we have found out is ij. Ij is 3.11, and if we have to find jh, it is ij plus ih. That is 3.11 plus 6, because this is 6 everywhere. Yeah, that supporting wire, smallest supporting wire, because we kept our axis there. So it is plus 6, so 3.11, let's add it. It will come to 9.11 meters. So the required length is going to be, I have not rubbed the working, so by chance if there is any error we can spot it, that is why. Comes to 9.11 meters. Very interesting, but if you don't do it the right way, you'll get stuck up. So understanding has to be clear, and one has to do it by practically visualizing things becomes very easy and interesting. So that's how you go about doing this. I think because it's a huge video, maybe we can wind it up here, and in the next video we can take the next problems. Thank you.